Good afternoon, ma'am.
My screen is visible.
Yes, ma'am.
Yes,
Okay, so
ma'am.
we were discussing the tutorial questions yesterday. We will continue now. So can anyone tell me the power at 30 degree and 70 degree?
2.875 watt at 30
2.875
degree.
30 degree.
Um,
Correct.
2.875 volts.
Correct.
1.875 at 70 degrees Celsius.
Just a second. Two point 875 watts. Power at 70 degree, it is 1.875.
1.875,
Okay, current value
4.11,
4.107.
4.11 ampere.
just a second.
2.67.
4.107 amperes.
Yes, ma'am.
2.68.
2.67
2.68 ampere.
amperes.
2.67.
Correct. Okay. Next question. What is the answer for the next question?
71 degree Celsius.
No, check once again. It is 72.5.
72.5 degrees Celsius.
72.5
Yes,
centigrade.
ma'am.
72.5.
Yes, ma'am.
72.5.
72.5 is the answer.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. Next question. Okay. Under ninth question, you have different circuits, right?
Yes, ma'am.
Yes,
So
ma'am.
one by one, we will discuss. I think circuit number A and B I have solved in the class, in the regular class. Correct? So once again, we will discuss. For figure A, for circuit figure A, what is the answer?
0.3
0.53
milliampere.
milliampere.
0.3
I
milliampere.
request everyone to type the answers in the chat box. Output voltage also 0.53 milliamperes. Output voltage minus 2.3 volts. Correct. Minus 2.3 volts. Figure B,
3 volts.
coming to figure B, tell me the current value and the output voltage. 0.3, someone has typed 0.3. It can't be 0.3 because circuit is reverse biased here. Please look at the current direction and the diode. So therefore the current which is flowing through the circuit is 0 amperes. No current flows through the circuit. What about output voltage? It is 3 volts. Correct. Right. This is the answer. Next. Coming to figure C. So in order to explain this figure C and figure D and figure E, right? Figure D and figure E. So there is a concept behind this circuit. First, let me explain that concept and later we will come to this particular problem. Okay. So here you have a circuit like this. Okay, so this is an example circuit I have considered. Say the input here is 5 volts. The input here is 0 volts. This is diode 1 and this is diode 2 and the resistance value is 1 kilo ohm. Okay.
And both are 5 volts input.
No, I just took an example. Later we will come to that circuit. This is an example problem. So here the question is, you have to find the current which is flowing through the circuit, and you have to find the output voltage. Find I and find V naught. So here there are certain cases you'll have to consider. We have two diodes with the two inputs. How many cases we can expect? We can expect 4 cases. That is 2 power 2 combinations. Okay. So that is, we have diode 1 and diode 2. I shall consider 4 different cases in the sense, what happens when both the diodes are forward biased? When both the diode D1 and D2 are forward biased? What happens when diode D1 is forward biased and diode D2 is reverse biased? What happens when diode D1 is reverse biased, diode D2 is forward biased? And the last case is that, what happens when both the diodes are reverse biased? Okay, here comes 4 different cases. With reference to these cases, you'll have to come to a conclusion and to find the value of current and the output voltage. Okay, so first let me consider first case, that is when both the diodes are forward biased. Okay, so when both the diodes are forward biased, what is the output over here? Say we are considering this also this as a silicon, and this is also a silicon diode. The drop across the diode here over here is 0.7. So 5 minus 0.7 will give me 4.3 volts. Correct? So here you have 0. 0 minus 0.7 will give me minus 0.7 volts. Getting? So we are getting 2 different voltages at the output side when both the diodes are forward biased. Do you agree with me?
Yes, ma'am.
Yes. So 2 different voltages you can't get at the output. So this condition is ruled out. We'll not get 2 different output voltages. So we can't consider both the diodes as forward biased. Did you understand? So first condition is ruled out. Coming to second condition. What happens when diode 1 is forward biased and diode 2 is reverse biased? Yes. Can anyone tell me? Coming to second condition, diode 1 is forward biased and diode 2 is reverse biased.
We get only one output voltage.
Exactly. So diode 1 is forward biased. So the drop over here is 0.7. So the output with respect to D1, we will get 4.7 volts. Getting? So diode 2 is reverse biased. Means I'll consider this as an open switch.
4.3, right?
I'm sorry. 4.3. Okay. So with respect to second diode D2 is reverse biased. So I'll make that as an open switch, right? So I'll get the output only with respect to diode D1, and that output will be equal to 4.3 volts. Did you understand? So this condition we can consider, that is diode 1 is forward biased and diode 2 is reverse biased. Now, let us move on to third condition. What happens when diode 1 is reverse biased and diode 2 is forward biased?
Output voltage.
Yes, can anyone explain? Can anyone explain? Diode 1 is reverse biased. It means that this you can consider it as an open switch. Okay.
And only one output will be there.
Wait. With respect to third condition, diode 2 is forward biased. So what is the condition for forward biasing? So this P should be at higher potential than compared to N. Correct? The drop with respect to the second silicon diode, that is D2, it is 0.7. So what you will get here at the output? What is the drop over here?
0.7.
0, and here this is minus 0.7, right? You'll get minus 0.7.
Yes, ma'am.
So V naught will be plus 0.7.
This is minus 0.7.
No,
Yes.
then V naught.
When you apply KVL, it is 0 minus 0.7.
Yes, ma'am.
Yeah.
Okay. So P is at, okay, in order to say the diode D2 as forward biased, so P should be at higher potential than compared to N. Then only you can say diode D2 is forward biased. So
Yes,
please look at this condition. P is at 0 volts and look at N. It is at 1 value, and look at the value of P, look at the value of N. Whether this diode is forward biased or reverse biased.
Reverse bias.
reverse.
This is reverse biased. It is not satisfying the condition of forward biasing. Is it not?
Yes, ma'am.
Yes,
Yes,
I'll repeat
ma'am.
once again. Yes, I'll repeat once again. The third condition is diode 1 is reverse biased and diode 2 is forward biased. Okay. So the condition for forward biasing is that, so P should always be at higher potential than compared to N. N should be at lower potential and P should be at higher potential. Then only we can say the diode is forward biased. But here, look at diode D2. The drop across the diode is 0.7, and here with respect to this junction, here we are getting minus 0.7 volts, and here you have the potential is 0. Here we have 0 and here we have minus 0.7. So whether this forward biasing is satisfying for this diode D2? No, right? Because P is at 0 and N is at minus 0.7 volts. Are you getting? So this is not forward biasing. I mean, this condition is not satisfying. So therefore, the third condition is also ruled out. Are you understanding?
Yes, ma'am.
Okay. If not silicon diode, if it was an ideal diode, you'll not get 0.7 at all. Say the diode is ideal. With respect to the previous, that is diode D1, diode D1 is reverse biased. What output you get with respect to the upper part? Here you will get 0 volts, correct? And here also you have 0 volts, and here also you have 0 volts. So for forward biasing, P should be at higher potential than compared to N. But here P is also at 0 volts and N is also at 0 volts. Whether this is forward biasing? No, right? Forward biasing, I mean, this is not at all, this is not the condition for forward biasing at all. So that is the reason the third condition is ruled out. Did you understand? You have to clearly analyze this by considering the values. Okay. Now we shall move on to fourth condition, that is reverse biasing. So what happens when both the diodes are reverse biased? Obviously, you'll get 0 output, but they're asking you to calculate some value of current and output voltage. You can't say the output voltage as 0 by considering both the diodes as 0. So therefore, the fourth condition is also ruled out. So we are left out with only second condition, that is diode 1 is forward biased and diode 2 is reverse biased. So therefore, we will get this is 5 minus 0.7, that is equal to 4.3 volts. This is the output. So what is the value of current which is flowing through the circuit? How do you find current? How do you find current?
V by R.
It is 5 minus 0.7 divided by 1 kilo. If you do, you'll get the value of current. That is 4.3 milliamperes.
Ma'am, how is D1 reversed biased in the last case?
In which case?
In the last case.
Last case?
Ma'am, how is
Come again?
D1 reverse bias?
No, I am considering the condition as both the diodes as reverse biased, both D1 and D2. If both D1 and D2 behaves like an open switch, you can't expect any output at all. No current flows through the circuit. And
Yes.
even the output voltage is 0, correct? But in the question, they're asking you for the given circuit, they're asking you to calculate some value of current and voltage, right? You can't assume both the diodes as reverse bias. That is not at all possible.
Okay, ma'am.
So that is the condition. That is the reason the fourth condition is ruled out.
Yes, ma'am.
Okay. Please analyze this once again. So I shall tell you one shortcut with respect to this question. Say when they give these type of questions in the quiz, what you'll have to do is, you have two branches, right? One is upper branch, one is lower branch. So compare the input voltages for both the branches. So here one is 5 volts, one is 0 volts, right? So the branch which has got higher input voltage you consider, and with respect to that particular branch, apply KVL, find current and find output voltage. Leave the branch with lower input voltage. That is one shortcut. Did you understand? So can you tell me, by considering this particular case, the circuit is behaving like which gate, whether AND gate or OR gate?
And
No. How it is AND?
just a hunch, not sure.
No, if it was AND, then this is for 0, 0, 0, 1, 1, 0 and 1, 1 condition. Even for 1, 1 condition, you should get the output, right? If it is for 1, 1 also we will have to consider, and for only for 1, 1 you should get the
XOR
output,
gate.
right? No, it can be either an AND gate or OR gate, not XOR gate. So this circuit behaves like an OR gate. This is an example for OR gate circuit. Please make a note. And this example, whatever I have explained, clearly they have explained in Robert Bolstead textbook. So those who are referring textbook, please go through the textbook. Clearly they have explained whatever I explained just now. Okay, once you go through, this is basically an OR gate circuit. Okay, you'll have to explain this problem with respect to these 4 conditions. You'll have to consider 4 different cases and explain.
Ma'am, if input voltage is same.
Okay, if input voltage is same. Okay, I shall write an conclusion over here. So the circuit is behaving like an OR gate. So if both the inputs are same, then one equivalent you will have to consider. Any one voltage you consider, as like we took for parallel, when we had a parallel branch, we took an
Yes, ma'am,
equivalent
understood,
of it.
ma'am.
Okay, consider an equivalent of it, and then find I and find V naught. If not, consider input with higher value to find I and V naught. Apply KVL accordingly. Did you understand? Did you understand? Next, moving on to next question. What if you have a circuit like this, the other way around, the opposite direction? So this is an example for AND gate. Did you understand? If it is AND gate, you have to consider lower value of input, apply KVL to find I and V naught. Did you understand? So lower value in the sense you'll consider 0 volts. This path you'll consider find I and find V naught. So you'll not consider this branch at all. By considering all those 4 cases, this branch will be ruled out. That will become a reverse biased. So please analyze this problem by considering both as forward biased. One is forward biased and the other one is reverse biased. Next, it is reverse biased and forward biased. Next, both as reverse biased. I'll give you this as an assignment. Okay. So can anyone tell me what is the output you get for this question?
Plus 0.7.
Output voltage minus 0.7.
How it is minus 0.7? It is plus 0.7. Please look at the polarity of the diode.
Yes, ma'am.
Please look at the polarity of the diode. Here the drop is plus 0.7, not minus 0.7. So therefore, the output voltage is plus 0.7 volts. How much is the current which is flowing through the circuit? It is 0
milliampere.
divided by 1 kilo. How much?
0.7 milliampere.
0.7 milliamperes. You understood, right? AND gate and OR gate circuit. AND gate and OR gate by using semiconductor diodes. This is how we build a circuit. Okay. Now I request all of you to take up the tutorial question, whatever I have given, and tell me the answer. Figure E and figure D. Here both the inputs are same. Take one equivalent of it. So what is the equivalent?
0.03.
Just a second. This is the equivalent, right? Find I and find V naught. How much you will get? What is I value?
1.30.
1.303 million.
1.303 milliampere and voltage is 4.3.
1.3 milliamperes. The output voltage?
4.3.
volts.
4.3 volts. Yes, correct. So therefore the circuit is behaving like an OR gate. Next, coming to figure D, I think. Okay, this is 12 volts. They have given this as 12 volts. They're asking you to find I. Here the input is 10 volts.
Ma'am, is V not 10.7 volts?
Correct.
Yes, ma'am.
Find I.
Minus 0.72 milliampere.
Correct.
Yes, ma'am.
Minus 0.72 milliamperes.
Yes, ma'am.
Others?
Ma'am, instead of considering forward and reverse bias, can't we just take 12 volt as the starting potential and then go in the opposite
You
direction?
can take. You can.
Ma'am, if two diodes has opposite polarity,
No, that is not possible. Only one diode will conduct if that is the case. You can take 4 different cases and check. Okay. Next. Coming to figure G. Figure G from tutorial.
I is equal to 1.1 milliampere.
Just a second. I request others to answer.
Ma'am, I is 1.3 milliampere.
Only
I
I am
equal to
finding
1.1 milliampere.
Omisha and Pawan. Only those students are answering. I request others also to answer.
I equal to 1.1 milliampere.
Okay. So first thing is you'll have to find loop current, right? What is IA
Yes,
and
ma'am.
IB values? I and IB, you tell me.
1.1 and 0.2.
1.3, right?
Yes, ma'am.
Yes, ma'am.
1.3.
1.3 and 0.
0.2 million.
0.2.
Yes,
Okay.
ma'am.
Next, what is the main value of current?
1.1.
1.1 milliamperes. Correct. So what is the output voltage?
0.3 volts.
0.3
Yes, ma'am. 0.3.
volts. Correct.
3 volts.
Next. Next question. Figure H.
Ma'am, total I is 1.3 milliampere, right?
Which one?
Previous question. Just
Previous question. What is your problem?
total current is 1.3 milliampere and the
No, how it is I minus IB, no?
Yes, ma'am. Total is 1.3. Across the diode is 0.3, 1.1.
yes, ma'am.
Across the mid diode, whatever is there, no? Silicon diode.
Yes, ma'am. That is 1.1.
That is
That is
1.1.
1.1. Yes, ma'am.
Correct. Loop currents are 1.3 and 0.2.
Yes,
Yes,
ma'am.
I equal to 4.82 milliamp.
No.
2.3
2.32 milliampere.
Ma'am,
2.32
2.3 to 5
milliampere.
milliamperes.
Yes, ma'am.
Wait.
2.32 milliampere.
So I can write this circuit as, so here you have two diodes which are connected in parallel. You can take an equivalent of it because both the diodes are same. And here you have two resistances which are connected in parallel. And they're asking you to find the output voltage with respect across 2 kilo ohm resistance. So this is 4K and this is 4K. They're asking you to find the branch current, right? And I'll take this as total current, IT. This is 10 volts. Okay. So can you tell me what is I total value? Can you tell me the total current which is flowing through the circuit?
2.325.
And 2.325 milliamperes.
It is 2.3 milliamperes.
Yes, ma'am. 2.32.
Yes, ma'am.
It was my calculation
Correct.
mistake.
And with respect to, with respect to branches, with respect to two resistances, the current gets divided. So therefore, this is I total divided by 2. Okay. Then this will become 1.16 milliamperes. Okay. So find the output voltage. How much you'll get?
4.65 volts.
0.65.
4.6. Correct.
4.6.
Okay. This is the answer. Okay. Coming to 10th question, I told you to leave the 10th question. If the students have solved by using Thevenin's theorem, then the answer is 0.109 milliamperes. So you need not solve. If any students have solved, then the answer is 0.109 milliamperes. You need not solve this because the concept is not there in the syllabus. Okay. Okay. Next, coming to 11th question. You have 3 circuits. Can anyone tell me the answer? Figure 4, figure 5, figure 6. So coming to figure 4, tell me loop currents IA, IB and main current I which is given by IA minus IB. And then find the output voltage. Give me these answers.
IA is 2.09.
2.09.
09. Yes,
Correct.
ma'am.
2.09 milliamperes. IB
1.125.
1.125 milliamps.
Milliampere.
1.125 milliamperes. Next, total
IA 0.965.
0.996
0.965.
milliamps.
Milliampere.
0.965. It means the diode is forward biased. Correct?
Yes, ma'am.
So get me the value of output voltage.
Minus
2.28.
Minus
2.28.
2.28.
It is minus 2.28
2.2.
volts.
yes, ma'am.
Minus
Yes,
2.28. Please verify.
Yes, ma'am.
Okay.
Yes, ma'am.
Is this over? Shall we proceed?
Yes, ma'am.
Yes, ma'am.
Figure 5. Yes. Tell me now. The current direction is upward, right?
Yes, ma'am.
Loop currents.
IA is 0.74 milliampere.
Yes, ma'am. 0.74 milliamp.
0.74 milliamperes. Correct. Next,
IB is 1 milliampere.
1 milliampere. Correct. Next,
I1 is minus 0.257 milliampere.
minus 0.25. Correct. So, the current which is flowing through the diode, you are getting negative value of current. So, therefore, the diode is,
Reverse biased.
diode D1 is reverse biased. Consider it to be an open circuit. Okay. Redraw the circuit by making that middle path as open because current is negative, and get me the new value of current which is flowing through the circuit. Rewrite the circuit and get me the new value of current.
Is it 0.317?
No.
I mean,
Is it
Is it
2.92?
0.934?
it's zero, right? Because the
Pavan per
opposites.
year, correct. It is 0.803. If you want me to write the circuit, I'll write.
0.774.
Let me write the circuit. Only the middle branch you make it open. The circuit is like this.
Excuse me, ma'am.
You have to find I new. Yeah, tell me.
Ma'am, in loop 1, the current is anti-clockwise. In loop 2, it's clockwise. So doesn't it mean that since they're both in opposite directions, the diode in the center is off? So the ID is 0, right?
In the sense, no. Come again.
Since the center branch can be considered an open circuit,
Open circuit, correct. So
ID should
therefore,
be 0, right? ID should be 0 amps, right?
ID is 0, correct.
Yeah,
Since the
but
negative value of current which is flowing through the circuit, we will consider current value as 0, correct. Since it is open circuit.
yeah, but I thought you just said 0.8 something, right?
No, it is minus 0.256 you are getting. No, when you do this is by numerical analysis, you are getting negative value. It means that the current which is flowing through the circuit is 0. So we are considering the circuit as open circuit. And now you have to redraw the circuit by making the middle branch, whatever you have, you make it open. Okay. Understood?
Yeah. That
So
I got.
this is
But
one.
I wrote ID is equal to 0 because the diode is off.
That's
So it should be
okay.
correct, right?
That's okay. You can write I value as 0 or ID value
Okay.
as 0. You can write
Yeah.
because it is reverse biased.
Yes. Okay, ma'am. Thank you.
Rewrite the circuit, find the new value of current, find V0. Apply KVL now, anti-clockwise.
New value of current is 0.77 milliampere.
No, please check once again. 0.803 I am getting.
Yes, ma'am.
Correct, no?
Yes, ma'am. Correct.
Yes, ma'am. 0.8.
0.803 milliamperes you'll get. Find the output voltage.
Minus 2.79, ma'am.
No, it is not minus.
It's plus 2.79.
Ma'am,
Yes, correct.
2.79.
Correct. So 2.8 volts.
Ma'am, will you be sharing the solution of the assignment?
Oh, here I'm writing, no, in the notes. Yesterday I shared the copy, right?
Yes, ma'am. Yes,
In
ma'am.
the same copy I'm writing all the answers.
Okay, ma'am. Yes, ma'am.
I'll share this copy. Okay.
Yes, ma'am.
So yesterday I have shared.
Yes,
Today
ma'am. Yes.
again you want me to share? After 1 week I'll share.
Okay, ma'am.
So whatever I complete within that week I'll finish and then I'll share. Weekly once I'll share.
Okay, ma'am.
Next. Coming to figure 6. Tell me the answer. I think you have got a resistor in between along with the diode.
Yes, ma'am.
Yes, ma'am.
So it is minus 3K into IA minus IB you have to do. Whether you have done?
Ma'am, I'm getting negative value of output voltage.
Correct. How much you'll get? How much did you get?
Minus 16.8.
No.
Minus 0.8.
No.
Minus 1.2.
No. Minus 0.68 I got. Loop current, how much did you get?
Ma'am, across G1, it's 5.6 milliampere.
No. I'll do one thing.
Can you actually
I'll do
solve?
one thing.
Across D1, I got 0.228 milliampere.
Can you actually solve this question? Because
Exactly. Exactly. Who told this answer? 0.228 milliamperes?
Ma'am, Vidhu, ma'am, 0.228 milliampere
Vidhu. Yeah,
across
Vidhu. It is
D1.
correct. Correct. Okay. Okay.
Can you
As
solve this
students are.
question? Because most of us didn't get the answer right.
Yes, ma'am. Could you please go through this question like from start to end?
Yeah.
Okay.
Thank you, ma'am.
This is the direction of current. This is D2, this is D3, and this is 1K, and this is 5 volts. This is the given circuit. Okay, current I1 direction is upward. I'll take this as IA and this as IB. So therefore, I1 is IA minus IB. So apply KVL and tell me IA value. So first, you tell me the KVL equation. Starting from this node, it is 5, correct?
Minus 3.
Minus 3K into IA minus IB because it is a resistor. And resistor, it is sharing between IA and IB.
Okay.
Correct? Next, you have a diode. This is 0.7. One more diode you have, minus 0.7. Next 1 kilo of resistor is there, minus 1K into IA, and that is equal to 0. This is the KVL equation. I think you have missed out here. Since you have got a resistor, you have to consider, and that resistance it is sharing between both the loops.
Ma'am, only if there's a resistance do we write IA minus IB?
Only if it is resistance.
Only if there's
yes.
a resistance. Okay.
Correct. Because in order to find the potential drop, listen everyone, in order to find the potential drop across 3K resistance, so in order to find V across 3K resistance, V is equal to I into R. Correct? So here I is, you have to consider both the currents, IA and IB, IA minus IB multiplied by 3K. Because with respect to 3K path, which current is flowing? It is I1, where I1 is nothing but IA minus IB.
Yes, ma'am.
Okay. So solve this, and you'll get two equations. You have to solve those two simultaneous equations. It is 4K into IA minus 3K into IB, and that is equal to 3.6. Take this as equation number 1.
Ma'am, minus 4K into I.
I'll take this as loop 1.
Ma'am,
Next coming to loop 2. Yeah, tell me.
the minus 3K into I, because like the minus is outside.
Minus?
In IA minus IB, the minus is outside, so it will be
Okay.
plus 3K IB and minus 3K IM minus.
Let's check once again. I think I have took minus sign common.
Okay.
And
Yeah.
minus sign I have took common, and 3.6 I have shifted towards that side.
Yes, ma'am.
Correct? Okay. Next, coming to loop 2. Can you apply KVL and tell me what you'll get? Apply KVL to loop 2. It is 2 minus IB into 1K minus 0.7 plus 0.7 minus 3K into IB minus IE equated to 0. Now we understood the difference between loop 1 and loop 2. In loop 1, priority you have to give it to IA. So that is the reason we are taking IA minus IB. Whereas in loop 2, you have to give priority for IB first. Okay. So that is the reason we are taking 3K into IB minus IA.
Yes, ma'am.
Right. Now, so if you solve this, you will get 4K into IB minus 3K into IA, that is equal to 2. Take this as equation number 2. Solve both the simultaneous equations. Tell me IA and IB values. Can anyone tell me the answer?
Ma'am, IA is 2.91.
Correct. 2.914 milliamperes.
B is
IB
2.6857.
2.68 milliamperes.
Yes, ma'am. 2.
So therefore, main current is IA minus IB. You'll get 0.229 milliamperes.
Yes, ma'am.
Next, find the output voltage.
Point 0.68 volt, ma'am.
Is it minus 0.68 volts?
Yes, ma'am.
Yes,
Minus 0.
minus 0.68 volts.
Yes, yes, correct. So I think this completes the tutorial, right? I request everyone to solve the tutorial again. Okay. So what I'll do is this weekend, probably Saturday or Sunday, I shall schedule a quiz. Whatever I have done till now, please go through whatever I have done till now. And yesterday I have shared the notes also. So I will schedule a quiz this weekend. So prepare for that.
Yes.
Ma'am, quiz topics until
Yeah, that is what till the previous day of the class.
Oh, okay. So whatever we've studied about VDC, IDC, all will come, right?
Which one?
VDC, IDC, RMS.
Yeah, everything.
all.
Starting from the class day 1 till now.
Okay.
Okay.
Yes.
Ma'am, also, is
Yesterday
there
you
any
gave one.
information on the CIE?
Come again. Yes, Mihira, you are asking something?
Yes, ma'am. I just wanted to ask if there's any information on the CIE that's scheduled for 2nd of Feb. If it's going to take
No
place that time.
information with respect to CIE.
Okay.
This is only case study. I will schedule quiz. This is not with respect to CIE.
Okay, ma'am. Thank you.
Just to test how much you people have understood. Okay.
Ma'am, so this will be on quick learn or you will be having it in the class itself, right?
The platform I'll let you know.
Okay, ma'am.
Okay. Either Google Classroom or Quick Learn.
Will it count for our
And it's
final grade?
multiple choice questions.
See, those things and all you should not supposed to ask. Your job is to study. The questions can be either of short answers or multiple choice or any kind of. Okay. So
And how
prepare.
many marks?
See, Satya, see how you can ask these things.
Ma'am, we can prepare accordingly, right?
Ma'am, will it be counted for the final grade?
Yeah, this will count. In the sense you have 40 marks for case study, right? For that,
Ma'am,
I'll
so this
count.
is a part of case study.
Experiential learning, case study. Under case study, case study includes your experiential learning and how well you respond to the class. And in between, the tutorials and all you have uploaded in Google Classroom, right? Even that will be graded. And then the quizzes and other assignments, whatever I share in the Google Classroom, even that you have to answer and you have to submit on time. Those things and all we will consider for case study.
Okay, ma'am. Thank you, ma'am.
Okay.
Okay.
Any other questions?
And yesterday you gave one
So-
more. I wanted to
Come again, Pawan, what did you say?
From yesterday's homework.
Yesterday gave one homework.
Ma'am,
Yesterday's
yesterday you
homework.
given problem as homework.
Oh, I think I don't have. I only gave you the questions. I don't have any answers with me. You solve among yourselves and you discuss among yourselves. Okay. I'll solve and I'll get back to you. I gave you only question. I don't have answer with me right now. Okay. I'm left out with another 10-15 minutes. The thing is that I have to start a new topic, that is filters.
7 minutes.
7
Huh?
minutes.
See, 7 minutes. Okay. So, okay, then shall we continue tomorrow?
Yes, ma'am.
Yes, ma'am.
You have any questions?
No, ma'am.
No.
Any doubts? Any questions?
Ma'am,
So please go
what
through
will be the
whatever I have done.
ma'am,
Yeah,
what
tell
will
me.
be the duration of quiz? I mean, is there any time
Max-
limit?
Yeah, maximum of half an hour. Within that only. I think I'll give not more than 10 to 15 questions.
Okay.
Okay.
Okay, ma'am. Thank you.
Maximum half an hour. Yes. We'll wind up and we'll continue tomorrow. Because if I start now, then again, you have any class in the afternoon?
Yes, ma'am.
Is it? Okay. So labs and all, they have started?
Not yet, ma'am. Labs.
Right now, experiential learning is going on, ma'am.
Is it?
Ma'am,
Okay. Okay, fine. Then we'll continue tomorrow. Okay? Yeah. Thank you, guys.
Thank you, ma'am.
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 Thank you, ma'am.